So good morning students. So today we are going to discuss the IIT-JEE NEET Foundation. The subject it is light. In the light the topic is refraction of light. See, refraction, reflection, interference, diffraction and polarization, dispersion, these are the observed phenomena of light. So in these all observed phenomena, the light has some characteristic like, see, in the reflection, when a light is incident on any plane surface, returns back to the original medium, or the bouncing of light. The bouncing of light from the surface of the reflecting surface from the surface is called reflection. So there are two types of reflection: regular reflection, irregular reflection, or scattering. That all comes under the reflection. But today's topic is refraction. Refraction is nothing but the bending of light when it travels from one medium to another medium. So the bending, the observation of bending of light. See, for example, you take there is a air medium and glass medium. Light enters from air to glass. The speed of light in air is different. The speed of light in air is, so that is speed of light in vacuum, let us take 3 into 10 to the power of 8 meters per second. But the speed of light in glass is different. So that's why, so whenever there is a change in the speed, we observe that light do not travel in the same straight line. There is some deviation from its original propagation. So that deviation of light or bending of light when it travels from one medium to another medium is called refraction. This is due to the change in the speed of the light in the mediums. See, the speed of light is different in different dispersive mediums. That's why here you take the refraction is the bending of a wave when it enters from one medium to another medium. Here, see, the one medium to another medium, the speed is different. That's why the bending of a wave we will observe when it enters from one medium to another medium. See, when it passes from fast, there is a speed of light in rarer medium is, so usually the speed of light, velocity of light in rarer medium is greater than that of denser medium. So in the rarer medium the speed of light is fast. In denser medium the speed of light is slow. That's why the speed of light is changes from medium to another medium. So when it changes the light ray, so there is a slight towards the normal, it bends or it away from the normal. When a light enters into the from denser medium to rarer medium or rarer medium to denser medium, see, if the medium has the speed of the light, you can understand here the speed is equal to the depends upon the refractive index of the medium. Refractive index of the medium. So the refractive index is nothing but, it is denoted by mu. Refractive index is denoted by mu. Mu is equal to C by V. C is nothing but the speed of light in vacuum divided by speed of light in the medium. See, if you know the mu value, you can find the speed of light. The speed, because the speed of light in the vacuum is constant. So based on the speed of light, if refraction is more, refractive index is more, that is called as denser medium. The refractive index is less, is called a rarer medium. Based on the refractive index, we can have the, see, whether light travels fast in the medium or light travels slow in the medium. Usually the speed of light is faster in the rarer medium. So here fast medium is nothing but the smaller refractive index. I told you just now. Okay, see, slow medium is nothing but greater refractive index. So when light travels from one medium to another medium, this is the normal, let us take the normal. So here is taken as this particular thing is called normal. Here light is see, when light enters from rarer to denser, So there is a bending, we observe it, there is a bending. See, refraction is responsible in the case of the lenses, the image formation, all those things are there. So when you visualized, the bending of refraction can be visualized with the help of Huygens principle also. See, there are propagation of the light, or see, the theories of propagation of the light. Theories of propagation of light, there are 4 different theories are there. So the first theory is Newton's corpuscular theory. See, Newton's corpuscular theory. Second theory, Huygens wave theory. Third one, Maxwell electromagnetic theory. Fourth one, Planck's quantum theory. So in all these 4 theories explains about the propagation of the light. The first, Newton's corpuscular theory. What is Newton's corpuscular theory? See, Sir Isaac Newton in the 17th century developed corpuscular theory of light. According to his theory, light travels in the form of corpusculars. Light travels in the form of corpusculars. Corpusculars means small, okay, see, some like cell like things, small particles. So that is corpuscular theory. Light travels in the form of corpusculars. See, light travels speeder in the denser medium and slower in the rarer medium. Light travels in different speeds in different dispersive mediums. See, light is emitted from the self-luminous body. It emits in the form of corpusculars. These corpusculars, so have, there is a big size corpusculars, different colors, small size, different colors. Colors are due to the sizes of corpusculars. See, these are the things explained by the Newton. See, these are only assumptions made by the Newton. But after that, see, these assumptions overcome by the Huygens principle, Huygens theory. What is Huygens theory? Huygens theory explains that light is a wave. Light is a wave. See, light is emitted from the body in the form of a wave. The wave travels equally, uniformly. Light travels uniformly with the, see, different directions. See, that's what he explained. Light is emitted from the source and it travels, so throughout the source, surrounding the source, it spreads light uniformly, it distributed uniformly, okay, so, and it propagates like a wave. There is a concept called Huygens principle. Huygens principle states that there is every point of a wave. See here, the Huygens principle, what it says, every point of a wave, it is something like a, see, it has its own wavefront and it produces another wavelet, and this wavelet and it creates, for example, this is the incident wavefront, plane wavefront. Once if it is emitted, see, incident on this particular hole, it spreads uniformly in all the directions. So these are the refractions explained by Huygens. Huygens explained that the refraction, how it is going to take place. Yeah, we'll come back to this later. The refraction, the Huygens thought that light is an electromagnet. See, light is a wave. So the light travels uniformly and medium is necessary. In the wave is produced only in the medium. That's why the disturbance in the medium is called wave. Huygens thought medium is necessary to propagate the light. That is one wrong assumption. And light, different colors are due to difference in the wavelength. He explained the phenomena like reflection, refraction, and other phenomena like interference, diffraction, and polarization. Of course, all those phenomena explained clearly with the help of Huygens principle and Huygens theory. So that is about refraction. In the refraction, so there is a faster medium and a slower medium. The indices of refraction, this is also important one in the refraction topic. See, refraction indices, it is denoted by mu or n. N is equal to C by V. What is C? The velocity of light in the vacuum and velocity of light in the medium. C divided by V, velocity of light in vacuum divided by velocity of light in medium. The index of refraction, n is the index of refraction. So the amount of bending depends upon the change of the refraction. The index of refraction, how much speed depends upon the change of refraction. Let us take, there are 2 different mediums are there. See, let us assume that there are the two different mediums. See, the first medium N1 is the first medium having refractive index, C by V1 will be there, and N2 is the another medium, so C by V2. Here if you find out N1 by N2, this is called a relative refractive index. See, the initial one is absolute refractive index, this one is relative refractive index. Relative refractive index is nothing but N1 by N2, if you do it, C by V1 upon C by V2. It means that V2 by V1 will come, V2 by V1. So here this particular thing is called the refractive index of first medium with respect to the second medium. The refractive index of first medium with respect to the second medium is nothing but speed of light in second medium divided by speed of light in first medium. This is called relative refractive index. Relative refractive index. See, coming to the values of refractive index, the values if you take, see, these are the vacuum, the refractive index is 1. The refractive index of air is also approximately 1.000027 is there. So the refractive index of water, it is 4 by 3, 1.33 approximately. The refractive index of glass, you take 1.5 something approximately will be there, 3 by 2 that is approximately. Crown glass 1.5 to 1.62 and flint glass 1.57 to 1.75. In all among this, if you observe, the refractive index of diamond is bigger value. The refractive index of diamond is 2.14, see 2.417, approximately 2.4. See, 2.4 is the bigger value. So this is the highest refractive index in the table. You can understand here. The refractive index is very, very important, and the refraction and the table of refractive indices. See, these are the different refractive indices. Air, ice, the refractive index is 1.31, water 1.33, 4 by 3 that is fluorite, glycerin, and crown glass, flint glass, rare earth filaments. All these are the different refractive indices, diamond 2.417 etc. So these are the refractive indices values. Based on the refractive index, the speed of light, it is going to be changes. For example, if you take the speed of light, okay, so is more, the speed of light is more, that is less refractive index. The less refractive index, rarer medium. So when it is in the rarer medium, the light travels from denser to rarer. Let us take light travels from denser to rarer. See, light when it travels from denser to rarer medium. See, let us take, this is the denser medium and this is rarer medium. See, when light travels from, this is the normal, let us take, light travels from denser to rarer medium. See, this one is called angle of incidence. See, the light, this angle, what it is called angle of incidence. This is the incident ray. So this is the separating surface, separating medium. When light travels from denser to rarer, it bends away from the normal. It bends away from the normal. You can understand, this is called angle of refraction. Angle of refraction. Here, let us say OA is called incident ray. AB is called refracted ray. Angle I is called angle of incidence. Angle R is called angle of refraction. Angle of refraction. So if you extend this incident ray, if you extend the incident ray, let us take this, if you extend. See, the angle between incident ray and refracted ray, the angle between extended incident ray and refracted ray. See, what is this called? This is called deviation. The deviation, angle of deviation. So, angle of deviation is delta. Angle of deviation is delta. Here, see, if you observe carefully, angle of deviation plus, see, opposite angles are equal. So, let us, this is also I will be there. angle of deviation plus angle of incidence is equal to angle of refraction. Angle of refraction here. In this case, when light travels from denser to rarer medium, the deviation is equal to, see, angle of refraction minus angle of incidence. Angle of refraction minus angle of incidence. When light travels from denser to rarer medium, see, the angle of refraction is greater than angle of incidence. Angle of refraction is greater than angle of incidence. These points you have to remember, very, very important. So, the angle of deviation is, it is r minus I. So, similarly, the reverse concept if you take, the reverse concept is what? See, when a light travels from, let us take, see, rarer to denser. The light travels from rarer to denser. So, when light travels from rarer to denser, let us take this the light ray. See, it travels incident ray. If it is incident on the surface, it bends towards the normal. The light bends towards the normal. This is the refracted ray. Here OA is called incident ray and AB is called refracted ray. So, the angle between normal and incident ray is called angle of incidence. The angle between normal to refracted ray is called angle of refraction. For example, you extend this incident ray. If you extend the incident ray, this is the extension of the incident ray. If you extend, and the angle between refracted ray and extended incident ray is called angle of deviation. Angle of deviation. So now if you observe carefully, angle of deviation plus refraction is equal to angle of incidence. Angle of, see here, angle of incidence is greater than angle of refraction. In the case of light, it travels from, see, rarer to denser medium, the angle of incidence is greater, angle of refraction is smaller. So that's why if you take here, see, the angle of deviation plus refraction is equal to angle of incidence. So it means the deviation, the angle of deviation is nothing but the angle between, what is that? The angle of deviation is the angle between extended incident ray and refracted ray. So angle of deviation is I minus R. I minus R here. So this is the way the concepts are very, very important. The refractive index, the refractive, so relative refractive index. So when light travels from denser to rarer, rarer to denser, so the refraction processes and the refractive indices, all these are important things. So the refraction also, not only in the light, the refraction also takes place in the sound also. The refraction takes place in the sound also. The refraction of sound we'll discuss later. And another important law, that is Snell's law. In the refraction, the Snell's law, see, the laws of refraction like laws of reflection. So there are two laws. The first one is incident ray, refracted ray and normal, all are lie in the same plane. The second law, that is, see here, this is the second law. The second law is nothing but, here if you take the angle of incidence and angle of refraction are related by a Snell's law. See, the angle of incidence and angle of refraction related by the Snell's law. So Snell's law is nothing but n1 into sin theta 1 is equal to n2 into sin theta 2. See, what is theta 1 and theta 2? n1 is the first medium, n2 is the second medium. Light travels from n1 to n2. So theta 1 is the angle between normal, and that incident ray. And let us take here, this is the incident ray and this is refracted ray. So n1 is, the theta 1 is the angle which is there present in the medium of n1. So theta 2 is the angle which is present in the medium of that n2 medium. So that's one, n1 is into sin theta 1 is equal to n2 into sin theta 2. That means n1 upon n2 relative refractive index, that is n1 upon n2 equal to sin theta 2 divided by sin theta 1. So these values, this is called Snell's law. See, simply Snell's law is also sine of, see, n is equal to sine of angle of incidence divided by angle of refraction. See, this is the books, okay, so elementary stage, the Snell's law, n is equal to sine I by sine r, n is equal to sine I by sine r, or mu, instead of n they will use mu also. See, n is equal to sine I by sine r. Sine I means what? Sine of angle of incidence. Sine r is nothing but sine of angle of refraction. So that n is the refractive index. In refractive index has no units, no dimensional formula. It is a constant in the light. You have to remember that point also. Yeah. This is about Snell's law. See, here there is one calculation is there. For example, if you take n1 value is, see, n1 value is 1. See, n2 value you take it as, n2 value you take it as 2. Theta 1 value you take it as, that is in degrees. Theta 1 value 90 degrees. If you take, then theta 2, what will be the theta 2? So how will you get theta 2 here? Or theta 2 you can take it as 45 degrees and you try to find out n1. Theta 2 you take it as 45 degrees. Then n1 value, or you can take here 1. Now try to find n1. Okay, we'll see later this. So this is about refraction. The refraction concepts will continue in the next video. Thank you very much.